So now we'll move on to things like the domain and the range. So the domain is essentially a set of input values, i.e. x values. The range is the set of output values, i.e. your y values. And so essentially what you may be given is you might be given a function with its domain, and you will be asked to find the range. And I think there are essentially three cases. You could have a linear function, and then so if it were to give you something like fx is 2x minus 7 for minus 3x. Okay, now this is an important way to explain your function notation. This just means y. It's just notation. It's another way of saying y. It's like saying this f of x means this f and these enclosing brackets is like a machine. It operates on x and turns it into something else, and it's saying, and it essentially means y. This could also be f like this. It's just another way of writing it. And also g of x, h of x, it all means the same thing. Just means like y. You got to imagine it just means y. Anyway, so for a linear function, essentially you just substitute both of your bounds in, and then see what happens. So f of minus 3, so your input goes in here. So it's minus 6 minus 7, which is minus 13. And then at 2, f of 2 equals 2 times 2 minus 7. That's 4 minus 7, which is minus 3. So we would say that the range is minus 13, and preserve these signs. F of x and so that's what you would do. And of course, if it was a minus, you'd have to just make sure your inequality signs are the right way round. Remember, more negative numbers are smaller than less negative numbers. Then you could also have a quadratic function, and the way we will figure out the range would be by completing the square. So if it was f of x equals 3x squared minus 10x minus 7, oh well, how about I use slightly different notation just for fun. And honestly, we just say, g of x equals 3x squared minus 10x minus 7. We begin to complete the square. Make sure you keep this neat. So that's minus 21 over 3, so it's minus 46 over 3. Okay, and then so now we've completed the square, and as we know, the vertex is that this is an essential. You wouldn't, if it asks for the range, you just need to do this, have this mentally as understanding, is that 5 over 3 minus 46 over 3. And because A is positive, it's going to look like this. And so notice how at that vertex, it's the lowest it can be. So that means g of x is going to be greater or equal to, because you've got that vertex, minus 46 over 3. And then, so, yeah, and then this thing here, you'd also get probably given that x is an element of this funny r. This means real numbers. So, not complex numbers, they're all real numbers. Anything you could put on a number line. This includes square roots, fractions, any fraction or whatever. So that's what that means. And so we're saying on the whole plane, in the whole graph, what's the range? And because the nature of the quadratic is it's always going to be at least that. And then the other case would probably be a reciprocal or rational function. Something with fractions or something. And maybe you might... And additionally for this, you might even be asked to do a domain, and there's a few reasons for that. So what if we had h of x? Remember, h of x just means y, We consider this. And say a question could be largest possible domain. And we pretty much just have to think about, okay, what works for this? What works? What numbers work? If we went very much, if we kept making this x smaller, so like -5, -10, all of that would be totally valid numbers, right? And if we kept making it big, like 100, 500,000, that would just make small numbers, right? Oh, sorry, not big numbers, really small numbers as you keep going further away from 0. But they're all valid values. But what if we did h of 2 equals 1 over 0? You cannot do this. You cannot divide by 0. So basically, that domain would be, okay, we can say x is an element of real numbers. It could be anything, but x cannot equal 2. Anything else, 2.1, it's fine. To 1.9, it's fine. But exactly 2, can't do it. And basically that would be on the graph represented by an asymptote. And then you could then ask for the range, and I mean, the range would be, well, it would be very much like this. So it'd have to be, it also cannot, it can equal anything. It would be an element of real numbers because it could equal anything, but h of x cannot equal 0. So that would be the three cases you could have for that. We might have something like an exponential, so like, for example, 2 to the power of x, you know that would look like that. You can't get it to equal 0, but x can be an element of any real numbers, it really doesn't matter. So what's it, h of x? H of x is always going to be greater than 0, strictly greater. And then if you had square roots, square roots can be a bit tricky. Say f of x equals x minus 3 minus 2. The best trick for let's first think about the domain. As we know with square roots, you can't, for real numbers at least, can't take root of negative. And AS, you can't take a root of a negative. So this needs to be 3 or higher. So x must be greater or equal to 3. And you can say x is an element of real numbers as well. And then if you think about that range, probably the best tip for range is if you've got brackets involved, try and make it equal 0 and use that to help you. And so if we make this 0, because remember, we can't go into negatives, so 0 is only the smallest it can be. Make that 0, that just leaves a minus 2 on the end. So that would be f of x is going to be greater or equal to minus 2, because then if we suddenly make that 4 minus 3 is 1 square root of 1, minus 2 is negative 1, which is greater than negative 2, so it's going to keep getting greater. This concept of making it equal 0 will be very helpful when we come to inverse functions and figuring out those. Additionally, another thing there is called a piecewise function. And essentially it's when they give you the function split up into different parts. So, say you're given this, and then it gives you the functions, but for it to be a function, it needs to specify the domains of each, so you don't get multiple answers, multiple output values. And what you would do is you may be asked to draw it or something, but essentially you just work out what each of these are and then plot them on the graph. And if I do this example, 9 minus 3 squared, that's just 0. And then if I keep going up, 1 minus 2 squared, it will go up, and then it'll keep going up, and then when it hits 0, it'll end up at 9, and then it'll start going down again, and then eventually we'll end up at 5. Then we at that we stop, and then we go for the 2x plus 1, that would be 5, and then we keep going up and as a line like that. And then if we were asked the range, you'd essentially go, alright, okay, the lowest is going to be 9 minus 3 squared, which is 0, and then the highest is going to be for this one, that one. 2 times 4 plus 1 equals 9. So our function will be in the range like that. And sometimes, say this was, if I change this to 2x, suddenly this no longer is a function, because at x equals 2, we could have 9 minus 2 squared, which is 5, or 2 times 2, which is 4. So then that would not make it not a function. There are some tricks they can still pull with piecewise functions. But it's just, they're very easy because you just handle each part one bit at a time, but just so you have an awareness of it and you're not weirded out when you first see it. Next, we will move on to composite functions in the next video. This is just some basics on domain and range and a few different cases that you need to know how to work out. There are a lot of questions on functions they can ask. This is just some basic knowledge that you need to take note of and then apply when you do